We hope you enjoy all the presentations. Before we start, I also want to welcome some of our past fellows have joined us already, and they're sitting among you here. At least two were at the colloquium we had 3 years ago and came back to hear you talking now. Others are from even before, and I hope we all enjoy ourselves. The presentations are going to be 10 minutes each. And we'll leave about 2 minutes for questions in between if anybody feels like asking questions. I have a little sign in my hand, and you should be looking at me from time to time, because I'll tell you when you have 3 minutes left, then 2 minutes left, and then 1 minute left, and that's it. But we won't interrupt you before you're really finished. Okay, so the first one is Yara. בבקשה.
Okay, thanks. I'm very happy and honored to be here, and I want to thank the, does it count on the time? But I want to thank the Rothschild Foundation for the kind invitation. So I'm going to talk about today how we represent narratives in the brain. And you probably, most of you ask yourself, why narratives? So the short answer is a quote by Stephen Jay Gould that humans are just primates who tell stories. And the long answer I will try to give you in the next few slides. So how do we represent a narrative? Imagine that your friend calls you and says that she's in the hospital and describes the event that brought her there. Now, in order to understand what she's saying, you need to create a model in your brain of what exactly she described, the events that she described. And based on many behavioral studies, the term situation model was suggested. So situation model is just the mental representation of the where, why, when, who, and what happened in the described events. My question is, how is situation model represented in the brain? And although I think that situation model is very central to how we represent the world, very little is known about the brain correlates of it. So I conducted 2 experiments. In one, I manipulated a text such that, for example, if we go back to the friend example, she can say, I'm in the hospital, or she can say, I'm in the cinema, and the way you will represent what she's saying would be very, very different. In the second experiment, the content was exactly the same, but the context was different. So again, in this example, she could say that she's in the hospital, but if you know that your friend is a medical doctor, it will be less stressful than if you know that she's an art student. So here, everything is exactly the same, only the why part is different. And today I'm going to tell you about this second experiment. So what we did, we had 40 subjects in the MRI scanner, and they listened to a 12-minute story, a story by J.D. Salinger, Pretty Mouse and Green My Eyes. This is a story about a phone conversation between 2 good friends that they came back from a party, and Arthur, one of the friends, could not find his wife, Joni, at the party. And he's calling Lee, the other friend, to share his concerns. Now, Lee came back from the same party, and there's a woman next to him. And the story is written in an ambiguous way regarding who exactly is this woman. And in order to disambiguate the story, we gave subjects one of 2 different contexts before that. One context was the cheating context, where it says that Lee is at home with Joni, Arthur's wife. They're having an affair now for over a year. The second context, Arthur is just paranoid. He always thinks that Joni is cheating on him, but actually Lee's at home with his girlfriend. He just want to go to sleep. And this manipulation affected the whole conversation between the friends. And in order to verify that, we also had a comprehension questionnaire. So what I want to do now is I want you to participate in my experiment. So if you can choose one of these contexts while listening to a small part from the conversation. So here we go.
Did you happen to notice when Joni was leaving? Did you happen to notice if she left with the Ellenbogans by any chance? The gray-haired man looked left again, but high this time, away from the girl, who was now watching him rather like a young, blue-eyed Irish policeman. No, I didn't, Arthur. Didn't she leave with you? No, Christ! You didn't see her leave at all, then? Well, no. As a matter of fact, I didn't, Arthur.
So, as you see, even though it was exactly the same words, your thoughts about what's going on in the character's head is totally different whether you think that they're cheating on him or whether you think that Arthur is paranoid. So let's see what our subjects thought. So we had different comprehension questionnaires. One was context independent with general questions like what did Joni buy Arthur once, and you can see here that both groups had very high and similar performance. And so for a question like what did Joni buy Arthur once, both of them knew that the answer was a suit. But we also had interpretation questions that were context dependent, such as why do you think Lee didn't want Arthur to come over? And you can see that there was a totally different pattern of response. So for example, somebody from the cheating group would say because he didn't want him to find out that his wife is there, but somebody from the paranoid context would say because he was tired and just wanted to go to sleep. So we were interested in the brain correlates of this effect, like finding finding brain regions that could discriminate between the two contexts, even though the stimuli was exactly the same. So what you see here in yellow are exactly these regions. So all these yellow spots had a different brain response to exactly the same stimuli as a function of the microworld that was created in the subject's brain. And these regions are very interesting regions that are part of the theory of mind network, comprehension network, memory network. And here what you can see is that there were time points in the story that had a bigger difference in the response. And if you go back and look what happened in these time points, so these are time points that are very important for the understanding of the situation where there's a very big difference between the two contexts. For example, when Arthur is telling Lee that Joni just came home, somebody in the cheating context know that he's lying and he's just trying to save his face, but somebody in the paranoid context will be like relieved that okay, everything is okay and everything is back to normal. And we also correlated this this difference in the neural response with the difference in the emotionals and of the emotions and intentions difference between the like the context-dependent difference in emotions and intentions, and we saw a very high correlation between difference in the neural response and difference in the intentions. So, for example, if there was a high difference in the neural response, there was also high difference in the intention. So it was not just a random difference. Finally, we tried to see whether all the brain cared about the same parts of the story, differences in the same parts of the story, and we saw that it's not the case. So, for example, regions that are involved in memory had a specific pattern across time in the story, whereas regions that were involved in comprehension had different pattern of response. So to summarize, the same natural stimulus resulted in different neural patterns as a function of context. Differences in neural response correlated with discrepancies in characters' intentions and emotions, and different regions differentiate between different parts of the story. So I think taken together, it suggests that we initially started to characterize the brain correlates of situation model. So to conclude, maybe it's a bit kitsch, but I really think that everything in the world we can represent using situation model, using the why, what, when, where, and who. So if we understand how we can, how the brain represents situation model, we could also understand how the brain represents the work. And I want to thank you. I want to thank Professor Hassan, my advisor, and my lab members, and of course the Rothschild Fellowship and the Weizmann Award for Women in Science that allowed me to pursue this this study in the best conditions. And that's it. Thank you.
Any questions? Yes, Elad.
Okay, so it's a good question. What we see here is more of the shared interpretation, shared response, because the way we're looking at it is we're looking at the whole time course and just correlate between different subjects. But it's true that the way Salinger wrote it, he wrote it that you would think like the cheating, you will assume the cheating context. So I think that if you're looking at it, there is more variance in the paranoid context because that's not the way you were supposed to read it. Yeah. Yeah. That's a very good question. So most of the research about situation model is actually behavioral, and the way that they're looking at which aspects are important for representing the situation, they're just changing one of them and looking at your like how fast are you in reading something. And they found that, for example, the why, like the intentions, the goal of the protagonist, this is the most important thing. And then, like there is some ranking in what is the most important thing. So I think that the why thing, you will always try to put something in it, even if there's nothing. But I can't answer it in terms of the brain because I just didn't test it yet. But I would assume that, yes, you're trying to do it. Like, you're trying to make a whole story out of it, no matter the information that you have. Yeah.
I think we have to stop and the rest will be at lunch or something.
Cool.
How do you differentiate between a generalized emotional response, say, amygdala, one you might say is specific to cheating, but it's actually an emotional response?
Yeah, so I think what you're asking is maybe all the regions that we see, all they care about is whether you feel happy or sad with what you're hearing. So first, it's a great question because it's very hard to differentiate between the two. Because when you build a situation model, so it depends on the actual stimulus, but it also depends on the outside context and the inner context. And this inner context is the emotion that you feel. So it's combined. It's very hard to discriminate between them. But the fact is that in this case, we didn't see differentiation in the amygdala, for example. So we did see in regions that are associated with emotions, for example, in the ventromedial prefrontal cortex. But most of the regions that differentiate were regions that are associated with theory of mind. And these are all the only regions that had a correlation with the actual difference in the story. Yep. Okay, thank you.
Number 2, Svetlana. What's the question? Is everybody Everybody
I just-
hot or cold or what?
That work?
Hot. Everybody hot.
In the meanwhile, thank you. In the meanwhile, I want to thank for Rothschild Foundation for the amazing experience on professional level, on level of networking, and on personal level that I believe will be nurture me for a very long time. So I will start. Just a moment. How do I change the slide?
You're asking the wrong person, that I would assume. No. Enter.
Yes. Okay. Avraham Uri Kovner is undoubtedly one of the most colorful figures of the Haskalah movement. One of the first critics of Hebrew literature, by the end of the 1860s, he grew disappointed with the direction of its development and switched writing in Russian, a language he learned only several years earlier. Unable to sustain himself from literary work, he started working in bank. There he found an opportunity to reinvent himself yet again, and this time as a romantic bank robber. In 1875, he perpetrated a bank embezzlement, was caught, judged, and imprisoned. Already from the prison, he contacted Dostoevsky, and marshalling Raskolnikov and rhetoric, asked for understanding, forgiveness, and assistance, and Dostoevsky answered him, and it was very important correspondence. Actually, the only known picture of him in which he looks so respected and authoritative is actually taken where? How do I move forward? I did it. Yes, it's actually taken from wanted advertisement published in the time of his escape. Kovner may have been the most odious representative of his generation of Russian Jewish writers, but his radical ideological, aesthetic, and personal decisions reflected the challenges posed by the very reality that molded the literature and the lives of other authors as well. This reality and the various creative strategies to fashion within its constraints plausible models of modern Jewish subjectivity are the central theme of my research. The figure of a criminal and outlaw, one who transgresses the limits of social norms while preserving the autonomy of individual will and agency, held a pivotal position in the literature of Jewish novelists in Hebrew, Yiddish, Russian, and languages who wrote between 1860s and 1880s. It was the time of the great reform in Russian society that followed the ascension to the throne of Alexander II. In this period, a new type of displaced Jewish intellectual was formed and consolidated. Encouraged by the promise of reform and emancipation, these intellectuals detached themselves from the traditional Jewish communities, their narratives and modes of identification, and headed towards the centers of Russian culture. The problem was that there was no place for them in the symbolic matrix of Russian society. Russian law did not presuppose the existence of individual at all as legal and administrative unit, and operated instead through the implementation of hereditary categories of classes and estate, which means for each class on estate it was different set of laws, not only for Jews. In this situation, Jewish subjects were confined twice, according to the prescription of the estates, and through the additional restricting regulation excluding Jews. In the Russian social and legal reality, a maskil, enlightened, modernized individual was potentially branded by multiple labels of transgression. By Jewish traditional society that perceived him as an apostate, by Russian authorities that wanted to transfix him into stable geographical and social positions, and by Russian literary tradition that used the stereotypes of dishonest, crooked Jew as a foil to defend against it the positive notions of being Russian. In a way, the fact of existence of educated Jew in the urban centers of the empire was already an act of transgression of the exclusive laws that prohibited Jewish dwelling in the imperial centers. Unsurprisingly, the motif of criminality and transgression appeared almost in every literary work written by Jewish authors in Russian and Hebrew between 1860s and 80s. It is possible to categorize this text not by the language barriers, but through the spectrum of possible positionings of modern Jewish subjects vis-à-vis the label of criminality and transgression envisioned in them. Because of historical reason, Yiddish literature in this period dealt only scarcely with the question of masculine modern self-fashioning and self-perception, and wouldn't be referred here. So what I imagine is kind of spectrum of positioning toward the label of criminality. And on one pole of the spectrum, we can find Peretz Smolenskin, this guy, one of the first advocates of Jewish nationalism. He sought to detach modern Jewish identity from dependence on non-Jewish cultural and political paradigms, and to establish an alternative discourse with its own centers and values. Of all of the crimes he associated with Jewish experience, and there were many, he was very critical to Jewish experience as well, but among all the crimes, informing Gentile authorities about Jewish affairs was the most severe and despicable. The inner communal system of justice was the only authority in Smolenskin's world to find a solution to the conflicts. But what should have done authors who insisted to envision Jewish belonging in the broader Russian context? In the center part of the spectrum, we can find literature that problematized the gap between the honest, authentic self of Jewish intelligence and labels of criminality projected on him from the outside. So, for example, Hebrew poet Yehuda Leib Gordon in his poem Shnei Yosef ben Shimon dealt with question of stolen identity and described a collapse of masculine self. Russian Jewish journalist and novelist Grigory Lifshitz perceived similar existential situations of rightlessness and misidentification not only as a tragic shattering of the self, but also as a reality demanding an adequate, pragmatic, and even satirical response. His protagonists were criminals against their own will, forced to adopt transgressive tactics in order to survive and overcome their legal exclusion. Gordon, Lifshitz, and other Russian Jewish writers protested against the discrepancy between, on the one hand, their self-identification of the characters and of themselves as decent and respectable members of society, and on the other, their labeling by dominant discourse as born criminals. But several Jewish writers in Russian, as for example, Grigory Bogrov, opted to eliminate the discrepancy and embrace figure of the criminal as its own subject position. This strategy was taken to even greater extremes by the scandalous member of this group and now old friend Avram Uri Kovner. Kovner took on the guise of the criminal not only as a narrative strategy for self-representation, but also as behavioral model in his real life. Kovner's crime was, of course, complexly motivated and followed from his individual psychology and life circumstances. Yet the particular expression given to these idiosyncrasies in his writing and in his life represented broader existential circumstances of Russian Jewish intellectuals. Already in the beginning of the 20th century, when he finished the sentence and worked as a respectful civil servant, Kovner published memoirs of his childhood. The work is generally cast in the familiar narrative mode of the Haskalah autobiographies. One exceptional episode stands out, however, and may seem unrelated to general narrative. Only when interpreted in the context of tradition of the masculine self-representation as a criminal do allegorical meaning emerge. In this episode, Kovner describes a scene of public flogging he once witnessed as a boy in Kovno. The scene has nothing to do with Jewish life in the city, and one can wonder what was the rationale for its inclusion in the narrative. It is the minutiae of Kovner's account, however, that reveal what I believe may be its real concern. Kovner describes in excruciating detail the construction of the scaffold, and this is just illustration from different area. The construction of the scaffold, the marching of the non-Jewish felon, the reading of the verdict, the procedure of flogging. So savage is the flogging, so violent is the raising of shackled felon, that at one point the rope that holds him on the bench became loose, and he is able to move on the bench when his bare genitalia exposed to all to see. Lingering on this agonizing moment, Kovner writes, "I could no longer watch, so I turned away." And this is turn away of his head is very important to my analysis. "I wanted to leave, but I was surrounded by masses of people and was forced to stay all the way through. Only now did I notice how the graceful and elegant Pani stood up in the carriages to have a better look at the torments of that man. Even at that time, it seemed to be outrageous and inexplicable that this delicate Pani, who would probably faint at the most incidental harm to the paw of the little pet dog, who would never let an unfamiliar man to take off his jacket in their presence, could relish here in public. The sight of a naked felon was begged the executioner was turning into a bleeding beefsteak. When Kovner turns his head from the scaffold, he resuscitates his own transition from being one of the crowd, an undifferentiated observer of the spectacle of power, to self-representation as a modern subject equipped with the ethic of enlightened and dignified penalty. This turn of the head is emblematic of Kovner's self-nativity as a modern individual. But this representation of a transformation uncovers the conflicted nature of Kovner's consciousness. Out of the array of horrific aspects of corporal punishment, Kovner chooses to single out the relation between gazing representatives of authority, Polish young women, and the naked criminal with exposed genitalia with whom he identifies. And it is important to mention that in other autobiographical Kovner texts, he speaks about his life through the perspective of his sexual experience, and the question of sexuality was very important for his self-perception. Through this reenactment, Kovner acts out his and Bagrov's strategy of self-fashioning and self-affirmation. It is precisely at the lowest point of his social existence, the nadir of his relation to others, beyond the borderline of shame, that the felon, as Kovner describes him, manages to transform his social positioning. Through this interpretative maneuver, Kovner turns over the social hierarchy, empowering the outcast on expense of objectification of noble female spectators. Kovner's imagination forces them not only to see the criminal as an agent of masculinity, but to perceive him as an object of desire, a position he would not have been able to occupy under any other circumstances, because, as we can see in the citation, in any other circumstances he would not be able to put off his jacket in their presence. So Kovner interprets this unintentional exposure of genitals as an act of exhibitionism. It is precisely this strategy, this masochistic surrendering of oneself to shameful branding, only to subvert this branding by the force of its own devices, that the radical anti-nationalist fraction of Russian Jewish authors adopted in order to challenge the Russian dominant discourse in which they wanted to be included.
Excuse me, are there any questions? I didn't ask, I forgot. Sure, yes.
Yeah.
Peter,
Oh,
please.
I was just curious, to what extent is the literature of these Jewish authors different from that of non-Jewish authors who deal with criminality and modern subjectivity? How much are they, I mean, you mentioned Dostoevsky, how much are they taking from other authors? What new elements do they add to that discourse? Is it reflected back on the non-Jewish authors that is said by the Gentile literary community? I'm interested in the interchange between Judaism and that.
In this period, naturally, Jewish authors were extremely influenced by what happened in Russian literary scene. Russian literary scene was absolutely not interested in Jewish authors, but figure of a Jew as archetypical criminal was the main star of Russian literature. In Gogol's literature, like Jew as a crook was a stable archetype in Russian literature. But naturally, when we speak about literature, the transgression is one of the main motives. One of the literary critics told that to tell a story, it's already act of transgression. In story itself, they are progressed through the transgressing obstacles, etc. But what is different in this literature, and it's really amazing, and it's only when you read it, not only in Hebrew, but in all three languages, you see how powerful phenomena it is. When in other literature, you see the normality, and you have some reference point for normality, and you see the positioning of the criminal relatively to normality. In this literature, the borders, in this specific period, the borders between the normal, legitimate, and crookish and criminal are effaced. And there is always the identity of the subject, of the protagonist, that is under question. After this period, it changes inside of Hebrew literature, because with introduction of nationalism, Jews represent or construct their own models of propriety, and it's very important. In this period, they don't really know who they are, and they act in the framework of Russian models, and therefore criminality is so central for their own self-perception.
Any more questions?
Hi, good afternoon, whatever morning, whatever we are. Thanks a lot for having me here. לא רואים? כן, לא רואים? לא שומעים? לא בטוח. בסדר? Hi, I'm going to speak today about something that's not the core of my research, but I thought perhaps would be interesting to a broad audience and maybe also provide some comic relief. I'm sorry if my introduction is going to be a bit broad, just to bring us on to the same level. We are quite aware that there's a biodiversity crisis happening in the planet today, and it's manifested in several ways. Biodiversity is defined as the diversity of organisms or biological entities, from genes all the way through to ecosystems, so very broad in its perspective. But in most cases, when we talk about biodiversity, we actually talk about species. So species is an entity like a frog, a tree, or that we can identify. It has a specific names. But as you can see, it's really hard to see here. So this, maybe, better over there. You can see, so somewhere around here is a very thinly lined gray area of the unknown number of species. And as you can see, part of the problem we have is that most probably of the species of animals and plants we still do not know. Apart from that, many of them are being lost every day in a very rapid race, very rapidly. Species we know more about, we know that do it between 10 and 40% are listed now in various degrees of being threatened, but most of the species which are found in this broad circle you can hardly see, we actually don't know anything about, and somewhere around 100 species will be lost during the day and a half that we spent here in this colloquium, and most of them we will never know. It's like burning books and libraries that we have never ever read, and this is done due to various human actions that some can be summarized here. Different people give different such presentations, but at the end of the day, various of our influence on nature, which are not direct, which are not killing animals per se, have great ramifications on diversity. Why should we even care about that? There are many, many reasons, and this is something that I'm personally very interested in, and I'll be happy to talk to you later about. But in general, we can define it by two broad aspects. We can be interested in conserving nature or biodiversity just because we think it's important, because they have a right to exist and so forth on and so forth. Or we can think that it actually benefits us to a great deal. And this is something I'm going to discuss a bit further today. And a few years ago, there has been a tabulation of the global GDP, which is about half of the benefits that we get every year from nature. So for every dollar that circles around our classical economic system, there are $2 that are circling around there that we get from nature basically for free, and this can be pollination services or creation of soil or water purification and many other things that we get from nature that in many cases we don't even think about. I want to talk about something a bit even less trivial, which is what we call well-being. Our well-being can be both health, or it can be perceived well-being, or our psychological well-being. And in the past 25, 30 years, there's been a growing number of studies that link our exposure to various aspects of nature with increase or improvement in our well-being. So next time you're unfortunate to recover from a major operation in a hospital, make sure that through your window you see trees as opposed to just a brick wall, because that will improve the time it will take you to recover. If you live in a neighborhood that has more trees or that has more exposure to nature, you're likely to suffer less stress and aggression, and there will be less crime in there and less fatigue. I've seen we have at least one pregnant woman in the audience, so if you want to suffer less effects of what we call tapeshet herayon, also spend some time in nature, that can also improve. If we take a classroom, we put some potted plants at the end of just at the end of the classroom, all of a sudden you see a decrease in various animosities between the students and much more retention of various knowledge and ideas that they have. So in general, nature does us wonders in many, many ways. Many of these studies, though, have been conducted on a very, very small scale, and also their idea of what nature is was rather nebulous, was rather vague, and coming from the field of ecology, we wanted something a bit more precise to put into the fry. So we tried to think about what is nature, which is a very big question in itself, what is happiness, probably even bigger, and to link that on various scales, all the way from the global to the very local, and see if we can find links indeed between something we can define very clearly as nature, which is in our case biodiversity, and various attributes of what is happiness. So our measure of biodiversity is species richness, so the number of species per country of these 6 different groups in almost all major countries in the world. Since these are log scales, since species don't accumulate linearly with area, we had to control for that, and in essence each country gets a number which represents how high or low it is on these regression lines averaged over the 6 species. Happiness was a bit more challenging. The Gallup polls for a few years now sends questionnaires to thousands of participants in each of the 160 countries it surveys, some of which are directly linked to what's called subjective well-being or happiness, and 2 of them are here, which is one you can think about yourself and think about yesterday. How much chance did you have to smile or laugh? And then I can have the percentage of people said we did or we didn't. Another question, which is maybe not directly, but some people or many people do think of it as linked to happiness, is just ranking your life on a scale from 1 to 10. And then we devise various indices of a lot of the questions, and we take these indices and we put them into a framework of also the environmental cost of this happiness. So if we put here the ecological footprint, we see maybe the country has a lot of happy people, but it actually costs us or costs the planet a lot to produce that. If we just look at simple correlations between our measure of biodiversity and these happiness measures, you can see there's a very great variance. You see that 2 of these measures scale up linearly and positively with happiness. However, 2 do not. So first of all, which question we ask or how we define happiness is really important. But we thought that we should probably go beyond simple correlations to a more complicated way of integrating a lot of various other socioeconomic, geographic, and environmental variables into it in what's in a partial least square path analysis framework. And here you see we have constructs that each country we had a lot of various parameters going into them, and to see how they interlink one to another. And when we ask again the question of smile and laugh, we see that biodiversity affects our happiness construct almost as much as socioeconomy, or about as much. So all of the money we spend on things that we perceived in modern economy to improve our life are probably as important to us as if we live in a less or more biodiverse country. When we ask the question of life today, though, that we saw before, it's much more a socioeconomic question than one linked to the nature we live in. Just to wrap things up quickly, there's a study we conducted at local scale that also linked these parameters. So people living in houses that have a lot of nature next to them, either which they walk on intentionally or unintentionally, we do see an improvement in their what's called a subjective well-being or happiness. And just to wrap things up, we want to say that we definitely do see these patterns. They're found both on global and local scales. But it's really important to see which question it is we actually ask. How do we define this measure called happiness? I don't know if some of you have seen I think in the last month in Nature, an article came out that showed that conservatives versus Democrats in the US, are they more happy or less happy? And it was conservatives report that they're happier, but when you measure other aspects of happiness via smiles or so forth, it was actually that Democrats show more happiness. I don't know on which scale you are on, but I hope you're happy. Thank you very much.
Questions? Any questions? Let's start with you all.
Yeah. Mm-hmm. So this index actually incorporates, it's called the happy life years, which is your happiness times your life expectancy. So this measure actually already includes in it. And we had something like 150 different parameters which we looked at per country, having to do both with people in them, their geography, their environment, and the economy, to see which are linked and try to link them via this path analysis model I just showed you. So, yeah. Yeah. So we hope that this, first of all, when we do a simple multi-model regression, we do control for them, but we think this sort of framework is actually better representing it, which we construct broad constructs of, for instance, social economy, which we measure by a whole suite of different parameters that are measured per country. And we see how they are linked to the other various constructs we have in order to, in essence, not just control, but also show the influence and the relative importance of these basically different links one to another. So this is how we hope to control for a lot of these things, and we think that above and beyond all of these other things that definitely influence our happiness, also something that has to do with our local nature influences. The mechanism that you hinted at is very, very difficult. Definitely on a broad scale, but that's something I'll be happy to talk about if you want.
One more.
Mm-hmm. Yeah, so you're hinting again towards the mechanisms, which are not that trivial. I think as far as hormonal measures, if I'm not mistaken, there are some works on that. Neurological, I think there's been start, but if you want, I can have a look and see. This is definitely not my field. Biophilia is a term that's, it follows a long list of terms of links between humans and nature. We can think about romanticism in the 19th century. We can think about a lot of other aspects where at the end of the day, many people feel a lot of these things that I've just shown when they are in touch with nature and they think close to it, they think more harmonious feelings. And this is, as you said, is manifested also in our brain and in our hormones. So I think this is really interesting possibility to study various things. What happens in our brains when we view or when we visit nature, natural settings versus otherwise. So empathy is one of the things that psychologists have been thinking about, feeling part of harmonious feeling, feeling part of a greater entity are other things. So psychologists have looked at various such parameters.
Can you hear me? Okay. First, this is a small talk about forgetting. So I'd like to start by apologizing that I forgot to put the logo of both the Yad Nadiv and the Israeli Institute for Advanced Studies. So thank you for inviting me. But really, I want to say thanks to Yad Nadiv for their really generous support, which enabled this research. So I'm going to talk about mechanisms of forgetting, and this is work I've done during my postdoc with colleagues in Toronto. His names are here. So there are two reasons for why we forget. Okay, let's go step back. Even though I'm a memory researcher, actually most of the information we acquire, we eventually forget. So forgetting is an important issue to look at, and there are two major reasons for why we might forget things we once knew. So one is decay over time, and this image is supposed to show you colors fading. So decay is often described in terms of like colors that fade, memories fade and decay over time. But another reason for why we might forget is due to interference from similar memories. And just to give you an example of what I mean by that, think of parking in the same parking lot almost every day when you go to work. So on a certain day, you might very well forget where exactly you parked because you have similar memories of parking at similar locations. So this is interference from similar memories. And so then the question comes, why do we forget? Which of these reasons is the major cause of forgetting? And as you can see from the references here, the research on forgetting has been going on for over 100 years now. And sort of seesawing between decay and interference as a major cause of forgetting. So there has been a major debate in the literature as to why we forget. Is it decay or is it interference? And round about the 1970s, researchers in the field sort of gave up on this question of forgetting and went on to study other areas of memory. And so this debate wasn't really fruitful at that point. And what we thought in our lab is that perhaps the reason why we couldn't solve this mystery of forgetting is that both decay and interference exert effects. So both are causes of forgetting. And what matters is how we remember. So how we remember will determine how we forget. The memory representations or the neural mechanisms supporting them will determine the causes of forgetting. And the reason we were able to make this, the reason we were able to come up with this theory is because of recent anatomical advances as to what we know about the brain region supporting memory. So I'm not going to go into it in very much detail, but just mention the hippocampus here in gray, which is a major structure involved in memory, and this has been known for a while already. But it's not the only one. So other structures, and I refer to them in general as non-hippocampal structures, also have an important role in memory, but each of the structures support different forms of memory. So again, the idea was that the way we forget, the reasons for why we forget, would be determined by the form of memory and the brain structures which support it. So this is a little bit about what we know about these brain structures. So especially over the past several years, we know more and more about the fact that the hippocampus is really a special structure in the sense that it represents even very similar stimuli, like these very similar ducks over here, or apples, in distinct patterns, as is illustrated here. So for this reason, we would expect the hippocampus memories depending on the hippocampus to be not very sensitive or not very prone to interference, because they're really distinguished well in the hippocampus. On the other hand, for non-hippocampal structures, this is not the case. So these two ducks would be represented in very much overlapping patterns. So for these kind of memories, interference would be a major cause of forgetting. Sorry for the format of the slides. So I'm going to present a little bit of behavioral data. So this is not an MRI study looking at these brain structures, but just a behavioral study using what we know about the behavioral, the functions of these brain structures. So our starting point was this. The hippocampus has been shown to support recollection. Showed this already. And recollection refers to memory which is accompanied by contextual details. So say you meet a person in the street and you remember not only that you know that person, but you can also remember, oh, I met that person a week ago in a party, and remember what music was playing, what you were wearing, and so on. So that would be referred to as recollection, and this type of memory is thought to be supported by the hippocampus. The second form of memory is known as familiarity, and this refers to the phenomenon I'm sure many of you can relate to, where you meet a person in the street, just know that person is familiar, know you've met that person before, but have no idea where you met them from, where you know them from. And the way we probe these two, so familiarity, is thought to depend on non-hippocampal structures. And the way we probe the recollection versus familiarity is using a very sort of naive kind of paradigm, but it's been used and shown very useful over the past 40 years, I think. And that's just asking participants, essentially, can you remember any additional contextual details? Not actually using the word context, but can you remember? And we give them a few examples. Or does the memory just seem familiar? And in my study, I study very simple stimuli, lists of words. And the way we probed forgetting is the following. So we looked at memory for each word after a very initial test, very immediate memory test, and in a final memory test, which followed our manipulation. And for each word or item, we gathered both old and new, so do you recognize this word as old in the context of this experiment, or is the word new to you in this experiment? And we also collected recollection familiarity judgments. Okay, so here are a bit of details I need to give you about the experiment to finally show you the impressive result slide. So we had the idea here was to directly compare, which hasn't been done yet, between decay and interference. And we did this in a between subject design. So we had 3 groups of participants. All groups had the same, were given the same phase 1 and phase 3. So only phase 2 differed. So phase 1 is this immediate memory test I told you about. Very simple. Participants are shown words one after another. At one point, words like both over here reappears, and participants have to then recognize it as an old word in this experiment. And then in a final recognition test, participants are presented again with words from phase 1 and completely new words. In the word condition, for this group of participants, we call this a high interference condition. We gave the exact same continuous recognition test as in phase 1 in phase 2. So the idea here is that very similar stimuli, words, should interfere with one another. Then in the music condition, phase 2 was the exact same duration as phase 2 in the word condition, so around 15 minutes in both cases. But here the task was minimally interfering, so wasn't supposed to exert much interference. And the task was pretty enjoyable even. Participants listened to short music clips and were then asked to judge which instrument played each of the clips. Then in a final third condition, the short condition, we gave the exact same music task, only for a shorter delay in time. So essentially, this comparison between the word and music condition taps onto interference, because in both cases the time, the duration is the same, but the level of interference is manipulated, whereas the comparison between the music and short condition is a measure of decay over time, 2 versus 15 minutes. And here are the results. So I think it should say here, these familiar memories as a reminder of those non-hippocampal memories. And what you can see here is that as we predicted, they're really prone to interference. So interference, the comparison between word and music, is really significant, but we see no effects of decay. And if you think of the example I gave you before of familiarity, like meeting a person in the street, it seems very logical that you might think a person is still familiar even after a very long time, even though the details, the contextual details, may have faded away. So this familiarity, as we might prospectively think, is really resistant to time, to the effects of time. But for recollected memories, those dependent on the hippocampus, we see the exact opposite pattern. So we see an effect of decay. These memories decay in time, and this has been shown a little in rodents as well, but no effects of interference. So the hippocampus really protects against this kind of interference. And the last slide, just to sum up. So we provided a unified theory of forgetting, which takes into account both memory representations and causes of forgetting. And have shown that hippocampus-based memories, which are recollected, are prone to decay over time, but are pretty resistant to interference. And the other way around for non-hippocampus-based memories. And thank you all for listening. And sorry. Thanks to my collaborators, and especially Mars Moskovich.
Any questions? Yes.
Yeah.
The person. So the data is still technically there. So it's just our ability to access.
Yeah. Excellent question. I know you always say that, but it is. We actually have a paragraph in our paper about that. So at this point in the research, I'm just looking at like the empirical manifestation of forgetting, whether at the point we're testing, you really don't remember. Okay? But you're right that forgetting is often defined as things you remembered once but can't remember now. But what I actually wrote in the paper is forgetting will also be things you don't remember now but can remember maybe later on. So we define it as not being able to access the memory trace at this point. Yeah, so what we know about actually, yeah, so the ideas regarding pattern separation in the hippocampus, so how, so these are supported by mathematical models as well, like neural mathematical models. I'm not an expert on that, but I can see how mathematical modeling can inform of an understanding of that, especially like when does interference exert its effects and what exactly is interfering. So I think these kinds of questions we could answer with modeling.
One more? One last question? Yeah.
Yeah, so it relates to a work, it's not work I'm doing, but work about reactivation. So when we reactivate a memory, it might, first of all, it's a way of actually deleting that memory, but it's also a way of like making it come back. So, sorry, I lost track of my thought. So I do think it's related a bit to the question he asked. I don't think those memories, the memories are completely gone. If we have a reason, so I'll give you an example I like. So if I ask you later on today what you had for lunch, the memory has started to fade. But if you have a good reason to remember that, like, okay, now you feel sick, So then that might reactivate the memory, and that would be a good way of, keeping that memory. But if there's no reason, no cue to reactivate, then it would probably fade. Like eventually, most of memories fade because we don't have much use for them.
Thank you very much. Our next speaker is Kathy, and by the way, I also want to say and thank, in the meantime, slowly, a few of our past fellows have been walking into the room from all kinds of academic disciplines. They'll be joining us for lunch, so just know that there are a lot of people here listening to you and enjoying.
Okay.
And enjoying.
Thank you. I'm going. How do I go to my slides?
What did he do?
Nothing.
No, not you. What did he do? Back? No. He doesn't do it. Nilaya sopa yo manigame ya. Katy, a ver, le mala. Katy, más grande. Hi, so
I'm Kathy, and today I'm going to talk about drug nanoparticles for induction of therapeutic angiogenesis. Whereas angiogenesis is the process of new blood vessel formation, and this is a joint project between Stanford Chemistry Department and Stanford Cardiovascular Institute. So I'm going to introduce you to the process of angiogenesis, and then I'm going to mention our strategy of inducing angiogenesis with small molecule drugs. And I'm going to talk about the formation of nanoparticles that we do in our lab and our attempts of curing heart attack in animal model with those particles. So, I'm sorry. So angiogenesis is a very important physiological process that in adults occurs usually as a result of an injury. It could be a traumatic injury in which the existing blood vessels are simply cut, or it could be an ischemic injury, such as in heart attack or stroke, where the existing blood vessels are clogged with blood clot or lipid deposit, or in diabetes, for example, when the blood vessels are just clogged by sugar deposits. In all those cases, growing an alternative blood vessels to bypass the clogged one would be extremely beneficial for functional recovery of the damaged organ. I have to mention that today there is no established treatment for inducing therapeutic angiogenesis, because usually the treatments that are offered for angiogenesis are big molecules like growth factors and big proteins that first have severe side effects when introduced to the body. Second, are extremely poorly bioavailable. They're huge, they're extremely rapidly washed outside the body because they're extremely water soluble, and they are also degraded in the body by enzymes, and so it's not a good therapeutic way to induce angiogenesis. So we decided to work with small molecules, and we decided to work with the molecules that as a side effect showed a capability to induce angiogenesis. So the first drug I'm going to talk about is the diferoxamine. You don't have to remember names. I'm going to refer to it as drug number 1. So drug number 1 is used to treat high iron in blood, iron toxicity. And when doctors injected this drug into patients, they noticed that there are some blood vessels formed around the injection site. And so we wanted to take it and take advantage of it as to induce angiogenesis. Now the problem with this drug is that it's extremely water soluble, so whenever you inject it, after several minutes it just washed from your body. So a very appealing way to introduce this kind of drugs to the body is by nanoparticles. Nanoparticles are particles below 1 micron that have a very promising goal in drug delivery. They usually increase bioavailability of drugs. So for very water-soluble drug, they can encapsulate them into protective matrix, polymeric matrix, and then slow down the release of the drug in the body. If we are talking about very water-insoluble drug, cutting the particle size of this drug actually enables to increase solubility of the drug in the body and also to increase bioavailability. So we wanted to form nanoparticles of drug number 1, and we did it by the following way. We first formed dispersive system, emulsion system of the drug inside water droplets, very tiny water droplets dispersed in continuous oil medium. At the second step, we wanted to extract all the solvents from the system, and we did it by supercritical carbon dioxide. Carbon dioxide is the gas abundant in our atmosphere, but when it's brought to its critical point, pressure of 74 bars and temperature above 32 degrees Celsius, it becomes supercritical fluid. Very interesting substance, having properties of a liquid and a gas at once. It can dissolve liquids or solvents as a fluid, but it can take it through the membranes and just out of the system as a gas because it's very highly diffusive. So the drying process with supercritical CO2 is very efficient, which enabled us to leave behind solid particles of the drug number 1 in nanometric range and to form nanoparticles in this way. So at the first step, we formed those nanoparticles. At the second step, we decided to check its angiogenic potential or the potential to grow new blood vessels in healthy mice. We injected those particles in a protective hydrogel under the skin of the healthy mice, and after 5 days, we already saw a formation of profound blood vessels, and after 3 weeks, it was even more expanded. So the result was good. Of course, we compared it to just a drug injected to the mice in the protective hydrogel, and we saw that nanoparticles are much more efficient. However, about 20% of our mice developed some slight inflammation, and then we were worried about those animals. And then we decided to add another drug in our system, the drug that will prevent the inflammation, anti-inflammatory drug, a common painkiller called celecoxib. And so we formed nanoparticles of this drug as well. I worked with this drug before, so I knew very well how to form the nanoparticles of it. The only concern was that if we add this drug to the system, it might decrease our angiogenesis, because that's what we saw in the literature, that the drug might have anti-angiogenic properties. However, when we combined the nanoparticles of 2 drugs together, we saw a much more profound blood vessel network developed, and it was, the effect was really impressive to our big surprise. And so we went back to literature, studying about this drug number 2, and we saw that almost every research that has been done reporting about suppressing angiogenesis, that this drug suppresses angiogenesis. Recently, there were some studies saying we can see that the growth factors, the molecules that induce angiogenesis, can go up after the treatment with the drug number 2. However, no one has ever tried this drug for induction of therapeutic angiogenesis. In our study, we found really impressive effect, angiogenic effect of these nanoparticles of this drug. Next, we wanted to check therapeutic potential of those nanoparticles that we created. For that, we took 20 mice with heart attack models, with induced controlled heart attack. 10 of those mice received control, empty nanoparticles, not without the drug, and 10 of the mice received drug nanoparticles that we formed, and we monitored the animals for 4 weeks. On the top of a very profound vascularization that we saw in drug-treated group at the site of heart attack, at the site of ischemia, we also saw functional regeneration of the heart muscle. The heart was able to contract much better after the treatment, and the morphology of the heart reminded the morphology of the healthy heart. I mean, the heart shape was almost comparable to the shape of the heart in this healthy mice. So to summarize, we were able to develop treatment based on two alternatives that were able to induce angiogenesis in healthy and ischemic tissues. We saw a functional recovery of the, or at least delayed deterioration of the function of the heart treated with our nanoparticles. And our future plans are to study this system in other ischemia models, such as diabetes or stroke, to monitor the vascularization process by some mass spectrometry imaging that is available in our lab, and to test other drugs similar from the same family of the drug number 2, whether or not they're able to induce angiogenesis. And the most important, I want to thank you all for your attention, and especially Rothschild Foundation for enabling me to go to Stanford and to do this exciting research. Professor Richard Zaire, who is my current advisor, Professor Shlomo Magdassi, who is my PhD advisor here at Givat Ram, the Hebrew University, Kazal Institute of Applied Chemistry, and I owe a lot to those people. Dr. Ramin Begi and Dr. Neufito from Cardiovascular Institute at Stanford are collaborators. Netanya and Asher, thank you all. And it's nice to be here. It's great to be here. Thank you all.
Questions? Yes. That is one of our old fellows.
Yes, so I forgot to mention the last slide. This is our future plan. You can just conjugate it with antibody and to target directly to ischemia, whether it's heart ischemia or any other ischemic region without the oxygen. So whenever you have the low oxygen, then the particles can go there. Well, the half-life I can answer, it's about 3 weeks, but we entrap them in protective hydrogel also. So our future plans, as I said, to target it without the hydrogel, and then we will see. But the second drug, drug number 2, is very hydrophobic, so I do believe they will stay there for longer time. And the second question was, why the, yes, well, I have some theory because the mechanism is different. So the first drug stabilizes some angiogenic factor, and the second drug, it was proven that it works on alternative pathway. But yeah, but we need to confirm with proteomics maybe, but I have the theory that can, I think can explain it very well. Sorry.
One more. Okay, this is the last one. Yeah.
Well, yes. Well, first of all, the drug number, we use it a little bit higher concentration. So it could be that in lower concentration it suppresses, but in higher concentration it induces. So we also have an idea of the mechanism, of mechanistic pathway, how it works, and I'm not going to go into details because it's complicated. And also, why no one has seen this effect is probably that the drug number 2 is always given orally. It is never injected. So you can't actually spot new blood vessels unless you measure the growth factor in your blood. So the drug number 1 is injected, and doctors saw blood vessel network developed around the injection site. And in case of drug number 2, it's usually given orally, so it's impossible to see. So I think this is why people never notice this tremendous effect.
Okay. Thank you very much. And now we have one more before lunch. I'm sure you're hungry, but it's worth expression. Yes.
I'll try to do.
No, I won't let you get me too long anyway.
Okay.
I missed the last elections, but I realized that there was some big hype about voting strategically. So I thought that would be a nice topic to talk about. So this is based on joint work with Omer Lev and Jeff Rosenstein from Hebrew University. And so the first thing that we think about when I say voting is political elections, but that's not going to be the topic of this talk. So I want you to think about other types of voting. For example, we can vote on like the right temperature for the room, right? Or we're actually voting all the time. Voting is essentially just a mechanism for aggregating information and preferences. For example, in product reviews, in peer reviews, scheduling meetings. Sometimes the voters are not even human. For example, we can aggregate rankings of search algorithms and use crowdsourcing and so on. And the question is where strategy enters in. Okay, so this is a picture taken a few months ago with my daughter's daycare. The kids voted on what they want to build in the playground. And they just used the most simple voting rule, which is plurality voting. So every kid had one vote, and they just put their vote on the board. There were four options that you can see them below. You can see they can improve their counting skills a bit, but essentially the candidate with most votes should win, and Castle had the most votes, and this was selected, and this is what they built eventually. And so we're going to talk about similar mechanisms. So suppose we're grown-ups, or we're not voting over zoos and stuff. We're voting, for example, what drink. Suppose there can only be one drink at the next meeting, and our voter here has a kind of strict preference order, which means he prefers Diet Coke over juice, over wine, over beer, and he has some idea of how others are going to vote. So this reflects maybe a poll that was done before, or a straw vote, or just maybe based on his on him knowing more or less the opinions of the other voters. This is more or less how they're going to vote. It might be inaccurate. So given this information, suppose you're the gray voter, how would you vote? Okay. Yeah. So who would vote for Coke? Yeah, Diet Coke, sorry. Okay, who would vote for juice? Yeah, a lot of people. Who would vote for wine? Yeah, try to ignore your own like real preferences over drinks. Yeah. Who would vote for beer? No one. Okay, so most of the people said they would vote for juice, and indeed we can think of maybe two reasonable outcomes here. One is to just stick with your inner truth and vote for Diet Coke, and one is to be maybe strategic and vote for juice. And in this case, it's very simple what it means to be strategic. And what we're talking about is theories that can explain or predict strategic behavior in more general situations, not just in just one, and taking into account there's more than one voter and they all have different preferences. Okay. So the contribution of our model is first to kind of separate what the voters think or believe about the world, of how they represent essentially the uncertainty in the world. Based on this, how are they behaving? What are the strategies that they apply? And on top of this, using or showing some empirical and formal results. Was there a question? Now, our model is, of course, not the first, and I don't have time to go into all the differences and similarities between our model and previous models. One difference is that our model can be explained in under 5 minutes. So that's why I'll present it. Okay, so essentially suppose that the information that the voter has is essentially this kind of non-committing poll or some point estimation, if you like statistics, of how others are going to vote. It's just like basically the score of every candidate. But we know that this is inaccurate. Okay, so on top of this, the voter has some uncertainty level, and this may be kind of an internal parameter, depends. So some voters can be more certain of this information or less certain of this information. And how that's going to be reflected, essentially, is just by adding some small or maybe large interval around the score of every candidate. Okay, so if the poll predicts, or according to the poll says that this candidate has 90 votes, then you're going to add or subtract maybe 10%. And same for all other candidates. Okay, so this was essentially the whole epistemic model, very simple. On top of that, I'm not going to write all the equations of the behavioral model, I'm just going to show an example which essentially shows what the voter does. So based on all the possible states of the world, based on these intervals that we saw before, the voter can predict which candidates even have a chance of winning. And we're not assigning probabilities of any sort here. So candidates above the threshold, they may win, and candidates below the threshold are believed to be unlikely winners. Okay, and based on this, the voter is simply going to vote for the candidate he likes most above the threshold. Okay, so this is the most preferred possible winner. Okay, this is the strategy. This is the whole model. And we call this a local dominance move because we can show that this candidate dominates in a certain sense his current choice. Now suppose that the voter actually does that. So suppose that we have a committee and everybody sits in the room, and that was the first vote, so we have like a scoreboard, and now one of the voters sees that actually is voting for an impossible candidate and there's someone else dominating it, so he switches his vote, says, okay, I'm changing my mind. So he does that. But others now may do something similar too, and they may also change their vote, they may also be strategic. So now the scoreboard changes. So now maybe a voter wants to move again, and so on and so forth. And the question here is what is going to happen. Now if you're a game theorist, then you care about notion of equilibrium, and equilibrium in this case, it's very simple. It's just a state where everybody are happy with what they're voting for. Okay, no one wants to change their vote. And again, if you're a game theorist, then the first question you'll ask is, okay, so does a voting equilibrium exist? And after that, maybe, okay, suppose it does exist, is this process going to converge or reach such an equilibrium? And again, suppose it does, then what can we say about this equilibrium? So the major contribution is essentially a theorem saying that if you believe me that this is how voters behave, then indeed they are going to converge in a very strong sense. So it doesn't matter how they start. So they don't have to start by being truthful. They can start from an arbitrary vote, and they can play in any order. They may even change their vote several voters at a time. They don't even have to have the same size of interval. They can have different different uncertainty levels, and they can even change their certainty levels throughout the process. They're always guaranteed to converge to a stable situation, to an equilibrium, and in particular, an equilibrium must exist. Now, what can we say about such equilibrium? This we studied through lots of computer simulations, and essentially we show that, first of all, it replicates some real-world voting patterns. For example, there's something called the Duverger law. It's a law by a political scientist who just died at age 98. And essentially it says that under plurality voting, almost all votes reach only two candidates, and the other candidates almost don't get votes at all. And we see this very clearly in the equilibrium of our model. We can also show, again, empirically, that the selected winner is usually much better than if everybody were just truthful in the first place. Now, if you're not game theorists, then you would ask, okay, so if people really act like this, maybe we believe you, but how do you know that that's what people really do? So we don't know if, unfortunately, I can't poke I don't know how to poke the brain like Yara does, but we are running behavioral experiments now with real human voters, and we're constructing a very large database with kind of thousands of human voters and how they act strategically in different situations, and hopefully that would help us to answer such questions. So finally, I hope I convinced you that the simple epistemic model can provide, in addition to the behavioral model, a reasonable explanation for voting behavior. And in other works, we also show that a very similar epistemic model can explain strategic behavior in other settings. For example, in online scheduling, this is here we show how people strategize in Doodle, in real votes in Doodle scheduling. And even in very different games, like when they're routing in virtual networks or in real networks, and hopefully it will be useful to explain strategic behavior in other situations as well. Okay. Thank you very much. So I didn't have like a slide with thank you for everyone, but of course I appreciate all the opportunities and so on. Maybe I'll go back. Okay. Yeah. So I'll first answer the first question. Okay. So where you converge to, it depends on where you start and also on the order. So even if we start from a certain state and then we let people change their vote in different orders, we may converge to kind of different endpoints or different equilibria. And in some equilibria, we may have more than a close tie of two. But in most of them, so empirically, we see that usually we have kind of two leading candidates and one of them is the winner. What was the second question? Okay, so if there are only two candidates to begin with, then there's no sense in being strategic. You have no reason to do anything except voting for the one you like better. So strategic voting becomes interesting when you have more than two candidates. Yeah. Okay, so these are, again, two separate questions. First thing, if there is noise or if some models are not behaving exactly according to the model, then again, empirically, it seems to be quite robust to such small changes, so it wouldn't change things drastically. A kind of different question is what happens if they don't have the same polls. For example, in the US, a lot of people who used to watch Fox News were really surprised by the results of the election because they were exposed to different polls than some of the other population. And here we assume that everybody are exposed to the same poll, and that's a good question. So is it still robust to kind of large changes? The population is fraction in their information.
One more last question. Then we have to go. We're running late, of course.
Okay, so yeah, okay, so empirically it's very fast. What usually happens is that like in over 90% of the moves, people almost always compromise. So they always move from someone they like better to someone that they like worse, and so on and so on. And they can only do that. Suppose you have n candidates, they can only do that at most n times. But since we also have moves in the other direction, then it's not a proof, it's not a formal proof, it's just what usually happens. So usually it's very fast because of what I said. So the theorem I presented says exactly that there can't be any cycles.
Okay, can you hear me? Yes. We are now going to have lunch at the Beit Belgia. So, and we are starting.